With so much hype about Yellowstone getting ready to erupt or being long overdue, it can be difficult to understand what's happening and what's true these days. We do know that Steamboat Geyser has come back to life, and has been erupting on a regular basis after being silent for many years. Steamboat is one of the more than 10,000 thermal features located at Yellowstone. Today we're going to review Yellowstone's active hydrothermal system, so we have a better understanding of what this is and what's happened within the park. Let's get started. Yellowstone National Park contains more than 10,000 thermal features, including the world's greatest concentration of geysers, hot springs, mudpots, and steam vents. These features are the visible expression of the hydrothermal system and the underlying hot ground and magma storage region deep below the surface. The hydrothermal system is located within the top few hundred meters or yards of the crust, whereas the magma storage region is several kilometers or miles below. The crust is the outermost major layer of the Earth, ranging from about 10 to 65 kilometers in thickness worldwide. The uppermost 15 to 35 kilometers of crust is brittle enough to produce earthquakes. The water that ends up in Yellowstone's hydrothermal systems comes from rain and snowfall that seeps down through the ground. It then becomes part of a groundwater system for the whole Yellowstone region. Within Yellowstone caldera, deeper groundwater fluids are heated as they circulate through rocks that overlay the magma storage region. It's here where the chemical composition of both the fluid and rock become altered by geochemical reactions. Heated and altered hydrothermal fluids that absorb gases and chemical compounds from the magma and crust. These heated fluids are lighter than colder groundwaters and buoyantly rise to the surface. When they near the surface, hydrothermal fluids mix with the cold groundwaters and deposit siliceous sinter or calcareous travertine that form the impressive cones, mounds, and terraces in Yellowstone's thermal basins. Hot springs are a natural outflow of hot water at the Earth's surface. They typically collect in shallow depressions to form thermal pools. In Yellowstone, hot springs can form from 1. Silica-bearing alkaline chloride waters, 2. Travertine-forming calcium carbonate waters, or 3. Steam condensation originating from fumaroles. Geysers represent a familiar and special type of surface expression of Yellowstone's active hydrothermal systems. They are especially abundant in the lower, midway, and upper geyser basins near Old Faithful. Geyser eruptions can occur on a regular schedule, like Old Faithful in Upper Geyser Basin, or can occur only occasionally and or unpredictably like Steamboat in Norris Geyser Basin. Geyser eruption intervals and activity vary due to changes in the subsurface natural plumbing system, some of which we don't yet understand well. All geysers require two fundamental features: 1. A subsurface reservoir where hot waters can accumulate and reach boiling temperatures, and 2. A constriction in the geyser conduit that provides throttling and focusing of erupting fluids. For a geyser to erupt, the subsurface reservoir boils, builds pressure, then ejects small amounts of water. When enough water is ejected, the pressure drops, causing the remaining water to become a steam-water mixture that is forcibly ejected through the constricted conduit. Geysers may erupt through narrow cones, large silica structures, or hot spring pools, called fountain geysers. Fumaroles are holes or cracks in volcanic areas that emit steam containing carbon dioxide and hydrogen sulfide. The gaseous mixtures form when magma in the subsurface releases gases that rise through and react with overlying hot water. In many cases, fumarolic steam condenses to form thermal pools at the surface. Hydrogen sulfide creates the distinctive rotten egg odor of sulfur gases. Bacteria thrive in fumarolic environments, and usually oxidize the fluids to be strongly acidic sulfuric acid. Mud pots are formed where steam and acidic fluids eat away at surrounding rocks. The remaining muddy mixture is made up of minerals including clays, pyrite, also known as fool's gold, and sulfates. Mudpots have a huge variety of colors including white, tan, pink, brown, gray, and black, and their fluidity depends on water supply and the minerals that make up the mud particles. Hopefully this gives you a better understanding of the hydrothermal systems at Yellowstone and will help you sift through all the misinformation and overhype on the concerns of the Yellowstone volcano erupting. Please subscribe, like and share.